It was a Friday night even, and it was about 10 p.m. And I got a phone call because I'm on call. Basically, the operator explained that the antenna stopped moving during setup.
This is Mike O'Brien, recounting a call that every ground station engineer dreads. The antenna is down, and you have less than 2 hours to fix it before the satellite needs to make contact with it.
I drove to site. It was exactly what I thought it was at the time. There was a software problem. And the antenna drove itself into a limit. When it does that, it kills power to the antenna, and it has to be manually manipulated to move out of that area. So I, put the harness on, got into the lift, went up to the axis. You have to open the housing doors, which is no big deal. And then you crank the hand crank, which physically moves the antenna, and it moved it out of that limit area. I had about 12 minutes left before the next pass started.
Let's take a step back to explain why, apart from strapping yourself to a lift 30 feet in the air, this is a stressful situation. A Landsat satellite orbits the Earth every 99 minutes, furiously collecting images of everything below it with each pass. Much like the storage on your phone quickly decreases as your pictures of cute dogs increase, Landsat's storage is also limited, which is why the satellite makes contact with the ground station every few hours to offload its data. But what if the ground station is down? Well, in that case, Landsat's internal hard drive fills up and doesn't capture the next round of images. Critical data is lost. Luckily, that is extremely rare, and data is hardly ever lost, especially with a workflow like this.
So every time a Landsat 8 image comes in, I record it on 4 independent different pieces of equipment. That way, if there's a failure, I still have 3 other great copies.
We couldn't really tell the story of data without mentioning Landsat's data renaissance, when a landmark decision changed Earth science forever. In 1990, Landsat data cost as much as $4,000 per scene. Usually, scientists require several of these scenes to do their research. As you can imagine, the cost was a major obstacle. In 2008, Landsat took down its paywall.
I recall having one of our international cooperator meetings. A woman from Russia was there, and she gave a briefing that really highlighted the importance of free data. Basically saying how it was democratizing for countries like hers, where suddenly you had an open source of information where anybody could get access and see what was going on the face of the Earth.
Kristi Kline manages the entire Landsat data archive, nearly 50 years of it. She knows firsthand how hungry the science community is for Landsat products. The first year's scenes were available for free. Downloads jumped exponentially.
In 2008, we had over 1 million downloads. And today, we typically get 15 to 20 million each year.
Which brings us to our next segment. Look at these. Stunning, right? Wrong. I mean, well, yes, they are gorgeous, but they are also a consistent record of change over time. At its most basic level, it's easy to see how Earth has changed since Landsat 1 launched in 1972. Just look at an early image and then compare it to a current one. Maybe it's changed a lot, maybe a little, but that's about all you can say. Landsat provides more than just pictures, though. From space, it sends back verified scientific data in multiple wavelengths. With Landsat, we can quantify exactly how much each 30 meter by 30 meter pixel has changed. And with the full Landsat archive available at no cost, you can track the complete progression of each pixel throughout the season. And you can do that for millions of pixels at a time. Has a piece of land changed from wetlands to suburban housing? Did forests become farmland? Or, looking closer, have these pixels of forest become stressed due to insect damage? Are those pixels of farm fields suffering from drought? With carefully calibrated Landsat data, it is possible to answer these questions for the whole globe.
It's a slice of human history. It's amazing how well, for this 50 years, we're documenting every change on the planet.
This is Jeff Masek, Landsat 9 project scientist.
My thing has always been history. My academic training is actually in geology, but the thing that I sort of loved about geology was still that kind of long time, right? It's being able to stand in a spot and say that, there was an ocean here 50 million years ago, and I can look at the fossils that are indicative of that. The thing that got me into the Landsat record was still that historical perspective. It's not 50 million years, it's 50 years, but still you're seeing before your eyes, how the environment how forests change, how agriculture changes, urban expansion, the whole thing, how the planet has changed over 50 years. And not only can you not conserve what you cannot measure, you can't measure the effectiveness of conservation approaches if you can't measure the change. So, we have limited resources, we have environmental pressures, we can do something about them if we have the right information. There's been almost an explosion in the number of Earth resources satellites, Earth observation satellites that are out there in the international community.